Okay, good morning everyone. My name is Tomáš Mráz. I am CTO of OpenSSL Foundation. Let me try this joke I've used last year as well, but I assume some people are new here. So, two cryptographers walk into the bar. Nobody understands what they are talking about. So, let me introduce Hunter Barton, Principal Security Analyst from Oracle, and he will have a presentation about how vendors, labs, and newbies can leverage public AI services during FIPS 140-3 validation. Please give him a warm applause.
Thank you. Okay, I guess it's time to get rid of the Uncanny Valley avatar. For those of you that don't know me, my name is Hunter Barton, and I'm a Principal Security Analyst on the Security Evaluations team at Oracle. If you've ever thought to yourself, how can I utilize AI in my day-to-day work, then you've come to the right presentation. Today's talk will be on how vendors, labs, and newbies can leverage public AI services during FIPS 140-3 validations. AI is everywhere. Ever since OpenAI came out with ChatGPT 3.5 in November of 2022, public AI services have quickly become a very valuable and unavoidable tool. Anyone working in IT can't realistically avoid or ignore these services without being left behind. Even in our niche segment of IT security, we must be able to adapt and leverage these available AI services. The goal of this presentation is to hopefully get your creative juices flowing by providing potential scenarios and examples that you may find yourself in, whether you're new to FIPS, an experienced lab manager, or even been with the vendor for 20 plus years. And remember that those who can imagine anything can create the impossible, as probably quoted by Alan Turing. Okay, I also wanted to mention a couple quick disclaimers. I will not be endorsing any AI models in this presentation. Everyone should, as a general strategy, use multiple models to verify results. And if you'd like to get my input on what AI models I prefer, please talk to me after my presentation. Also, be sure to stay compliant with NIST Handbook 150 and 150-17, a FIPS lab must adhere to before using AI services. If you're part of a lab and are unsure if you can use these AI services, just talk to your lab manager beforehand. Okay, I need a little bit of participation from each of you. I want you to please raise your hand if you've experimented with an AI model such as ChatGPT or Gemini in your spare time. Okay, that's what I thought, to be honest. So now please raise your hand if you're using AI daily or even a few times a week as a tool to assist you at your current job. Okay, that's actually more than I thought it would be. That's good. Okay, before we get into some examples on how we can utilize AI tools, we first need to get a better understanding on some basic AI terms so that we're all on the same playing field. First, a generative AI model is a broad field of AI design to create new content such as text, images, and audio. A multimodal large language model, or MLLM, is a specialized type of generative AI that can simultaneously process and understand multiple input types such as text, images, and audio. Some examples include ChatGPT, Gemini, Grok, and Claude, just to name a few. For some background context, say MLM's trained data is usually the default that AI will look for to figure out the answer to the prompt, while searchable data is used to override or supplement the trained data if need be. Lastly, a hallucination is when a generative AI model such as an MLM produces false, nonsensical, or ungrounded information while presenting it confidently, kind of like me right now. Okay, so let's imagine this first scenario just to get our feet wet. It's a little easier one to start out with. So you're interviewing for a summer intern position with the NV-Lab accredited laboratory authorized to perform FIPS 140-3 validations. The interviewer wants to know how fast you can learn while on a time crunch and hands you a laptop. The task assigned to you is to get familiar with the FIPS models and process statuses and report back your findings in 10 minutes. Your brain starts to ask questions such as, what does FIPS stand for? And what exactly is even module? Then you start to type on a laptop and think to yourself, is this company really that cool if they chose to buy silver MacBooks instead of space gray MacBooks? Okay, let's focus. You have no idea where to even start looking for this information. Now you could go down the path of trying to find out if the information you're trusting is where Google properly indexes and ranks the proper web page, or you could just try navigating NIST's website until you find the right web page, assuming you know what NIST even stands for. And I believe the most efficient approach is to just reword this question into your favorite AI-powered chatbot. So let's see this interaction on the next slide. Firstly, note that this interaction with the AI model took place before CMVP updated their statuses last month, so don't harp on me too much. With that being said, you can see I asked the question, summarize the FIPS models on process status and provide the link where you got this information. The AI comes back with a bulleted list for each status in the MIP list, and now I want to point out some key takeaways from this interaction. First, I asked for a summary to get into the output. Second, I didn't use the acronym MIP to avoid any ambiguity. And third, I asked for a hyperlink in order to confirm the information was correct and the AI wasn't hallucinating. Okay, if you look at this screenshot from the provided link the AI model gave, it shows the different statuses you think all stages are included. However, if you look at the MIP list and linked that the AI had linked, it's missing an on hold status that's clearly listed in this paragraph, so the answer provided isn't 100% correct. Okay, moving on. How about having an AI model write your 2026 ICMC abstract? Wait a second. This is not supposed to be shown here. Let's just move on. Okay, I need like one of those neuralizers from the Men in Black. That y'all didn't see that, right? Okay, so let's imagine this next scenario as a vendor. You're asked to present a brown bag about the importance of post-quantum cryptography. You need a way to make sure that the right people in your organization watch your presentation. Sending out a meeting invite with a topic and quick description will probably go unnoticed to most people in a big organization. So what if we instead made a quick teaser trailer for your brown bag using an AI video generator that's attached to the meeting invite? So here is one example.
Quantum computers are coming. When they arrive, today's encryption could collapse in an instant. Join our virtual brown bag to explore the importance of post-quantum cryptography. Friday, April 24th at noon Eastern, live on Zoom. Are we doing enough to prepare?
And then here is one more example.
The quantum threat is real. Are we doing enough to prepare? Join us via Zoom on April 24th.
Well, I don't know about you all, but after seeing this, I definitely have some more anticipation for this upcoming brown bag than a standard invite would normally be. This only took maybe like 5 minutes to create, and it was only like 2 sentences of a prompt, so pretty helpful. Neither trailer is very long, and the resolution is standard definition, so it should be able to fit in an email attachment. You can also send these clips via instant messenger to get the word out even more. Okay. Let's imagine this next scenario as a vendor. Your boss, Sarah, asked you to create a finite state model for your company's OpenSSL module that's currently under the IUT list. The problem is that Sarah asked you in merely 2 hours before this is supposed to be presented to the lab. Most people would drop everything they are doing and try to put something together in their favorite diagram editing software. You, however, like to take the stress out of a task like this and know that AI is your Swiss Army knife. You can use AI to your advantage in this situation. So let's see how this escalated task could be handled using a different AI model. Okay, if you look at the screenshot, I've asked the AI model to generate a finite state model block diagram using a format .drawio that's used by the draw.io application. This is an app that's widely used for creating block diagrams. I then asked the AI model to utilize the write-up given by the engineering team, which went into detail on what states were present in the module and the flow between each state. The AI model output a .drawio file in XML format and described how I could upload it to the draw.io app. As you can see from the next screenshot, that AI isn't perfect, and I got an error when trying to open the file. So the first time it doesn't work, right? So the easiest solution, rather than looking up the error, was to directly just tell the AI model what error I was getting. In my case, I got a not a diagram file error. The AI model apologized, gave an explanation on the correction, and provided me a fixed version of the draw.io file. Okay, so here's the block diagram that the AI model created for me without me even making a single modification. It's pretty pleasing to look at the block diagram with a color coordination such as error states and its associated arrows being in red. The states are nicely spaced out, and the diagram is easy to understand. The diagram may not be 100% to everyone's liking, but remember, this took me only 10 minutes to complete. I could spare some time and spend another 10 minutes arranging the diagram to my liking, and I would still have time to work on my other tasks I was working on before this urgent email had came in. This really does put a different spin on the famous quote, "Poor planning on your part does not constitute an emergency on my part." Okay, how about one more example as a FIPS vendor again? Your boss has instructed you that you must start utilizing AI as much as possible. Recently, you've been spending quite a bit of time making sure that a specific branch of UEK, which is Oracle's Unbreakable Enterprise kernel, has all the FIPS relevant patches to be considered FIPS compliant. Let's see if we can use an AI coding agent such as Codex or Claude Code to help develop a web app that sifts through FIPS patches, because who doesn't like a nice GUI to look at? Okay, so if you look at this image, I've asked the AI coding agent to create a web app that pulls the Oracle Linux UEK from GitHub, copy the repo locally on my laptop, list the branch, let the user select a branch for the last commit since 2018, find the commits that reference FIPS, IG, and 56A, and let the user select and search those commits separately. I also chose commits since 2018 specifically as an example for this presentation to find the SP156A Rev3 assurance patches, as the standard was published back in April of 2018. The AI coding agent took about 10 minutes to complete this Python 3 app for me, and it does quite a bit of work as it sifts through 8 years of commits across 18 UEK branches. Okay, so hopefully you guys can see this. Looking at the left image first, you'll see a snapshot of the web app. The app lets me fetch the latest repo and load the latest UEK branches. Oops, sorry. I can select what branch of UEK I'd like to look at through. Here, for example, I chose the UEK next branch. I'll then search for all commits that reference the FIPS in this branch since 2018. And after about 10 to 20 seconds, it comes back with a list of commits by date published that reference the FIPS in the patch. Reference FIPS in the patch. The agent was also so kind to hyperlink the commit hash for me as well, so I can go look at the patch in person on GitHub. You can also see there's 233 commits that are found by the web app, which would greatly help me figure out this branch is FIPS compliant or not. If you look at the right side image, I wanted to know if this branch has the patches relevant to the SP156A Rev3 assurances. So I chose to search for 56A, and the web app came back with 70 commits that were relevant to 56A. As you can see in the image, there's some of the patches that I was hoping I'd find when I created this web app. The nice thing when using an AI coding agent is that this app can be expanded upon, such as adding the 90B health test patches with a simple request to add it via one-line prompt to the AI coding agent. Or here's an idea. How about having an AI coding agent code an app that takes all releases of OpenSSL and have it check to see what high CVs are applicable to each version of OpenSSL? Just some food for thought. What previously would have taken days or weeks to develop can all be done in one afternoon now. Okay, let's imagine this next scenario as a FIPS tester in a lab. Your colleague asks you to help him create a GDB script to automate the cat failures in libgcrypt. For those of you that don't know what GDB is, it's the GNU debugger, and it's an open source command line tool used to analyze and fix runtime errors in programs. For FIPS cat failure specifically, it's usually used to modify the computed or expected value, such that the self-test fails and the tester gets to observe how the module reacts to the failure. Okay, for demonstration purposes, I decided to show only a small portion of the task. We'll be here all day pretty much. We'll look at how to write the failure for SHA-256 cat only. Using the AI model again, I asked the AI to provide a GDB script that fails the SHA-256 cat on line 90, which for reference is the memory comparison on the computed digest and expected digest value happens. I also asked the AI model to modify the digest actual variable before the memory comparison is executed. And the AI model then explains that the digest variable is a pointer to the buffer containing the newly calculated hash, and flipping bits in the buffer would ensure the comparison against the expected digest fails. In this screenshot, the AI model provides a GDB script to fail the cat. It's also nice to see that the AI model added comments for us to better understand what's happening without even asking. You can see that the breakpoint is at line 90, right before the mem compare, just as asked. If algo equals 8, which is linked to the SHA-256 algorithm, then we'll run all the commands such as printing the detection and also show the original first byte in the digest. We'll then XOR the first byte. with all ones and store that back into the digest variable. We'll print the corrupted first byte of the digest and state we are about to fail the cat. Now the question is, does this work? Well, on paper this makes sense, and the cat should fail. However, there may be issues that can't be spotted until the tester runs the script and tests for themselves. Either way, the AI model has helped tremendously here and jumpstart the task assigned. It's up to the tester to get across the finish line. Lastly, I wanted to know if the AI model could tell me the calling sequence that led up to the specific memcompare line in the libgcrypt code rather than trying to find the calling sequence manually, either by downloading the code or traversing through GitHub. Evidently, the AI model provides the calling sequence, which again saves time and energy used. Remember though, you need to verify that this calling sequence is correct if you want a 100% guaranteed answer. Okay, let's imagine this last scenario as a FIPS tester once again in a lab. You're trying to complete a source code review document and are trying to find where in the upstream Linux kernel that the IGC.I resolution number 1B XTS key check takes place. Specifically, the explicit module check that key 1 and key 2 are not equal. Let's see if AI can help us sift through the massive amount of code that the Linux kernel has while also assuming we have no prior knowledge on the structure of the Linux kernel source code. Okay, this time I asked two AIs the exact same question. Let's call them AI number 1 and AI number 2. I asked both AIs to provide me a snippet of code where IGC.I resolution number 1B is satisfied, provide the IG hyperlink, and then used both AIs' way of thinking longer since I'd consider this a more complex task. Looking at the left side, AI number 1 states that the XTS set key function within crypto.xts.c source file contains a check with a memory not equal function. So this looks like AI number 1 found the right place, right? However, this is 100% a hallucination, as this snippet doesn't exist in the as the snippet doesn't exist in the XTS set key function when investigating. There isn't even an older commit removing this snippet, so we can't put the blame on old trained data. Okay, let's see if AI number 2 can figure out this right place. Looking at the right screenshot, AI number 2 states that the check is in a function called XTS verify key located in the include crypto XTS.h header file. AI number 2 shows that the implementation of the function in the second if block in the screenshot is what we were looking at. Once again, it looks like this is the snippet we've been looking for. However, AI number 2 is also hallucinating, but in a different way than what AI number 1 did. Okay, see the screenshot of the true implementation of the XTS verify key in the upstream GitHub repo. AI number 2 was not only missing the key link check to make sure that 256 bits or 512 bits was allowed in the FIPS configured kernels, but had an incorrect conditional expression. Now AI number 2 helped us find the right place, but we could move on with our next task, but I still really don't feel quite satisfied with this. I'd really like one of the AI tools to come back with a 100% right answer, so why don't we try another AI? This time we'll call it AI number 3. Okay, here's AI number 3 being provided the same question as the other two AIs. AI number 3 finds the correct function and its respective header file similar to AI number 2. AI number 3 also has the proper full implementation of the XTS verify key function, unlike AI number 2 did. And most importantly, the conditional expression in the last if block is right this time. See the paragraph below where AI number 3 was also so kind to break down what's happening without me even asking. So what's the lesson here? Is it that we should be using AI number 3 only to help with our source code related task? No, that's not the right answer. The answer is that we should be utilizing multiple AIs to help with our questions. And I didn't show it, but just for everyone's knowledge, another AI, let's call it AI number 4, also got this question right. I've also asked multiple AIs a wide range of tasks such as finding the 56A Red3 Diffie-Hellman and elliptic curve Diffie-Hellman assurances, as well as the DRBG used as a conditioning component through the Linux kernel's get random syscall. Usually one or two of the AIs would get it right, or enough right that I could go investigate the real source code myself. Okay, my last example today doesn't have a fun little scenario because I decided to add this into my presentation at the last minute, 35,000 feet up in the air on my way to ICMC. Here you'll see a short pre-recorded demo where I show a work-in-progress web app that I'm creating with the help of an AI coding agent. Hopefully you guys can hear this because I recorded this like at 1 in the morning a couple nights ago.
In the overview tab of this web app,
You'll see a work in progress dashboard that I'm developing, which includes the current IUT and MIP list statuses. Also included is a table and a line graph breaking down the modules and processes statuses of the last year with the help of many Wayback Machine snapshots. There's also a median queue days the average module will go through for each status in the MIP list, and a median queue days the average module will go through to get certified. This is similar to the FIPS queue time statistics Alicia Squires posts in the CMUF, and yes, this data isn't quite right yet, so it's a work in progress. If we go to the specific module tab, you can select a specific module from the MIP list, or the IUT list, or the active modules certification list. Here I chose the Oracle module, specifically the Acme Packet module that we have currently in the MIP list. As you can see, it tells me some useful information such as the current status, the amount of days of each status so far, and the time distribution pie chart. Okay. I think at this point you could all see that trying to develop something like this on an airplane by yourself would be almost impossible. But I got most of this done in a few hours on a super fast 5 megabits per second Wi-Fi, connections constantly dropping, and all while eating terrible Southwest provided pretzels. So we'll see how far I get with this in the coming months, but if there's enough demand to use a tool like this in the industry, then I'll see about having this web app hosted on the CMUF website for anyone to use. Okay, before I'm done talking today, I'd like to give my final thoughts, tips, and safety concerns when utilizing these public AI services. Firstly, make sure the AI isn't hallucinating and the data is legit. Don't upload confidential information. Users should always comply with their organization's guidance and policies when using public-facing AI resources for work-related purposes. And discuss with your colleagues on what prompts seem to work and what doesn't with your MLM of choice. Remember that the quality of your answer is directly related to the quality of your question. Outputs to complex questions aren't usually reproducible between model versions. For instance, ChatGPT version 4 and version 5 will give different answers, and Gemini and Grok will also give different answers to complex questions. You can use different MLM models for specific tasks. For instance, with ChatGPT, you can state in your prompt to think longer to solve a more complex question. With Gemini, you can use its thinking model or the pro model for math and code related tasks. And Grok also has this auto setting that will choose its fast or expert model dependent on the prompt. If you want AI to sound like you, then you can provide it documents that you've written to it, or you provide it documents so it learns your writing style and your writer's voice. This is great for drafting emails to your boss. I might have used that a couple times. So yeah, think of these AI services being equivalent to having 100 personal interns by your side, just waiting for their next task by you. For complex questions, feel free to run multiple chats across MLMs or create multiple chats within the same MLM. It's a mouthful. That way you aren't waiting around for a response. In conclusion, I believe AI is here to stay. It's best to be skilled using these AI services. Many of these AI services have free tiers available, with everything you see in this presentation being done with the help of AI. I also want to point out that I haven't spent a single dime preparing for this presentation. It costs $0 to invest in yourself, your future self, so please go out and try it for yourself. Again, my name is Hunter Barton, and if you have any follow-up questions, feel free to reach out to me at hunter.barton@oracle.com. Thank you.
Any questions? I hope it's...
All right, love this. Can't say it. Have I seen this before? Let me just... Here's a comment, and I think maybe somebody people have used AI might think about this. AI has this crazy way of talking to you that is kind of like a sycophant. It really, it's always so complimentary of whatever you're doing. And that can give you an overconfidence in the work that you're doing. Is there a way to train AI to be much more critical of the work that you do so that it doesn't feel like, it's your mother telling you you're the best ever?
Yeah, I actually had this conversation with my wife maybe like a week ago. I mean, everything you tell it, you ask for it to be more critical about you, it'll do that for a bit until you reload the app the next day, right? Like, it doesn't really remember that. And so, yeah, having it being critical of you at this point in time is, I don't think, the goal of AI services. Like, I mean, who doesn't want to use an app that's always critical to them, right? They want to use something that's always positive. So at this time, I don't think so too much.
Other questions? We have still a lot of time.
Hey, Hunter. Good to see you again. Caleb Crawley from Red Hat. My question to you is, I know you explained that you like to use a bunch of different models because they all have different features that you enjoy, but do you have a go-to model that you like to use?
I can't say that on recording, but afterwards I will tell you.
Understood.
Okay, thank you very much again.
Thank you.
Okay, for the second talk from this track, let me introduce Kurt Roloff, who is CTO and co-founder of Duality Technologies, with his talk, Open Source Homomorphic Encryption, Making It Real.
Great. Well, Tomáš, thank you very much for the introduction. So, hi everybody. I'm Kurt Roloff. I've spent the better part of the past 15 years trying to make homomorphic encryption increasingly practical, usable, and I've even quit multiple jobs so I could work on this technology and keep it pushing forward. Yeah, I know, fight the good fight, right? But through it all, I've been trying to make sure that the core technology is open source and practical and ready for real world use. So OpenFHE is a library I co-founded with several colleagues a few years ago with some very, very happy funding from US government and a few other places. And the technology, since, when I first started working in this technology back in 2009, 2010 timeframe, the concept of the technology is I'm sure, actually maybe we should even start. How many people are even familiar with the basics of homomorphic encryption? A few of you, most of you, okay, that's cool. So as you know, you take data, you encrypt it, you can compute on it. And so way back in 2009, 2010, what it was is you could take 2 bits, the very first implementation, take 2 bits, encrypt them, run a bitwise AND operation on 2 bits. For those of you that were kind of around at the time, anyone remember how long it took to do that, to do just the bitwise AND operation? It took a half hour just for a bitwise AND. Yeah, I know. Somehow DARPA got really interested in it. I'm really happy about that. And where we are now is, and I'll get into this kind of in the talk, is we have production deployments of this technology for doing things like secure query operation, quantum secure type stuff. We even have demos of running encrypted LLM inference, FHE encrypted LLM inference operations also. Not quite full scale, equivalent of like BERT Mini and things like that, but things that will run in the kind of scale that's actually usable for those kinds of things. And I'll get to that in a little bit also. But one thing I particularly wanted to talk about was not so much a kind of, horror stories or war stories about, making this thing faster, but what does it mean to kind of take a library like this, take a technology, create a library, start to engage standard bodies like ISO and NIST, start to kind of engage policy folks to actually get this technology approved for production use in things like financial services and for example, ICO, the Information Commissioner's Office in the UK, which is kind of like their version of a policy body for privacy technologies, has basically deemed the technology acceptable for things like anti-money laundering investigations. and other kinds of financial crimes and things like that. And I kind of want to talk about what does it mean to take an advanced technology like this and bring it in actual real use and get it accepted for use also. So, and I know I'm an open source, tech talk between two AI talks. So I appreciate, kind of sticking around and doing this. But there will, you can't get away from an AI agenda. I will be talking about a few AI applications also as we go. So yeah, introduction to FHE. It looks like I don't really need to do that so much in this talk. Particularly talking about the library that we have. For those of you that are interested in it, we're part of the NumFocus ecosystem, which is kind of like one of the main open source consortia. That does a lot of work in Python, although our library is in C++. Out of curiosity, does anyone ever have hands-on experience with OpenFHE? It's okay if you haven't. That's all right. Go and try it. It's awesome. It's very easy to find online. And talk about a few applications and some actual real products and projects that we're building on top of it, and where we can actually do things. And it's actually at a point where we've had demos working where we can do encrypted voice over IP on commercial data networks using FHE protected mixing of voice signals and things like that also. So, the future is always the future, and so we're always talking about what the next big thing is that we're going to be building out and kind of going from there. So, homomorphic encryption. I'm going to breeze through this. It sounds like a lot of you have some familiarity with kind of the basic precepts of it, which is cool. This is not like a deep cryptographer's talk, although I'm happy to get down and dirty kind of during the break and things like that. So basically allows for computations on encrypted data, enables outsourcing of data storage and processing. There's all different kinds of variations of FHE for symmetric key operations, public key operations. And one thing that I've learned or experienced over the years is one of the nice things about these lattice-based ring learning with errors schemes in general is that they're really malleable. You can do things like proxy encryption, threshold encryption, all these little kinds of bits and pieces of various kinds of goodies that one can use for advanced operations on data. And the concept's been around for a while. Ron Rivest and the company have kind of poked at it back in the late 70s. But the real breakthrough was in 2009 with Craig Gentry, and there's been a steady kind of drumbeat of these capabilities. And I'm going to be talking more in the context of public key versions of the cryptography, where particularly you have a public key, send a public key to a data source, send the data source to, use the data source to encrypt, send only encrypted data to the host, run computations on the host, inference operations, things like that, send a result and decrypt and black magic, because the decrypted result is what you get outside. And these things, they don't work in isolation. One of the things that we're doing as a company at Duality Technologies is, yes, commercializing FHE and making it real, but there's also a lot of mix and match that's been going on in terms of combining FHE with federated learning, with TEE-based technologies and things like that. And it's the right tool for the job. And although we like to put a lot of checkboxes around FHE for the things that it does have a lot of capabilities. And I come at this where I'm not a cryptographer by training. I'm an engineer. I'm a control engineer, actually, by training. And I think about FHE is kind of like what it exposes is that you take data, you encrypt it, and then you have a limited set of operations you can do on it. Like things that look like, if you squint, things that look like vector addition, vector convolution, modulo details and whatnot. And what it does is that when you have FHE encrypted data, it's almost like you're given this really reduced anemic instruction set of operations that you can compute on. And so what you do is you kind of start with FHE-based operations, and on top of there you can build libraries for basic arithmetics, vector algebra, statistics, and kind of go on up machine learning and kind of go up the stack. And that's the path that we're on with OpenFHE and a few of the other community efforts is basically building up, and what we provide in OpenFHE is not just a crypto library for encrypt and keygen and stuff like that. It's all the evaluation operations that kind of sit on top for like the vector algebras and things like that. But at its base level, there's things like, Boolean logical operations that you can support. There's all kinds of arithmetic type things in terms of just integer type operations. And as you also kind of go up, floating point type operations also. And, it's very good at vectorized type operations, and, we'll get down to details later. But, so it is. And it's got a lot of very funny design trade-offs also with it. That, if you've ever done assembly programming, you're probably, very familiar with, like, for example, like program counter and how many clock cycles things take and stuff like that. And generally when you're dealing with, like a reduced instruction set computer or otherwise, generally things take Boolean operations take the same amount of clock cycles, and integer operations take the same amount of clock cycles. Admittedly, division takes longer than multiplication and everything else. When you're dealing with FHE, what you're wrestling with is that the multiplication operations take an order of magnitude longer than the addition operations. And it causes some really interesting research challenges and design challenges for how do you design efficient algorithms where you have to kind of rethink your design trade-offs for things like logistic regression training and things like that to maximize the number of addition operations and minimize the number of multiplications. And so that's something that we worry about quite a bit in the community. And there's other variations of this, partially homomorphic, somewhat homomorphic, which really just kind of talk about what's the kind of extent of computation, how deep of computation, how complex of computation that you can run. And the major thing is this fully homomorphic, which includes this really strong bottleneck operation called bootstrapping, and it's arbitrary computation in theory, although in practice, simpler is always better. And one major thing that we did, and kind of one major thing that's kind of making this technology real, has been community effort around standardization. And so very, very early on in the community, let's say like 2012, 2013, there was a growing interest in how we could start to define security standards for these technologies. And engaging with some of the community at NIST, NIST is great. NIST is part of the Department of Commerce in the United States. I don't know if there's any NIST people here in the audience. Maybe there is, maybe there isn't. NIST's mission is to enable interaction and commerce in the United States. Perfectly fine. And they tend to get very interested in things once they can kind of point to companies actually building products and doing commerce with technologies. And so what we did early on as a community is we created this organization, homomorphicencryption.org, that was starting to basically set security standards for these things that kind of grew out and was always intended to be a temporary organization to make recommendations to ISO and NIST and engage with policy organizations like OSTP at the White House and places like that to basically talk about how this technology was ready. And so we had organizations like IBM and Intel and Microsoft that were kind of all involved, that was able to kind of be a core genesis for this, or kind of building out community interest in these technologies. And I'm very proud of that work and very happy to kind of talk about it at length also. But what ended up happening is it actually, sparked some interest in ISO, and ISO now has standards based on these security settings that community kind of put forward. And NIST is now working on a set of threshold FHE capabilities also, which is also quite nice, part of the current work items. And apologies if I get the terminology a little bit wrong for some of the NIST people that are here in the audience also. And so as part of that also, there's been this growth, not just in engagement, but the growth in engagement has been driven by growths in performance also. And so I have this S chart that I like to kind of show about how the performance of FHE has basically moved forward over the years. And over the decades, we've basically gone from things that take 30 minutes for a bitwise AND operation, and basically improving by orders of magnitude every few years. And so these are amortized operations, because homomorphic encryption, the fundamental operations are vectorized, complex vectorized operations, but we're basically getting down to amortized nanosecond type runtimes for individual Boolean gates over the years. And increasingly going from things where we're just doing really, really basic additions and multiplications down to doing things like, secure 5G network slicing, doing, general workloads, and even designing ASIC hardware, custom ASIC hardware to actually go and accelerate these workloads also. And so the core of this is a library that we've been pushing forward called OpenFHE, openfhe.org for what it is. Very proud to say it's export compliant. Also very happy, as some of you might be aware, because it's based on ring learning with errors. It's quantum secure, if parameterized correctly. And so I can't be grateful enough for DARPA and a few kind of friendly organizations that have, put in initial funding for it, but there's been a broad uptake in government use for this in places like NIH and CDC and a few corporate organizations, Raytheon, CACI, Intel, Samsung, AWS, and otherwise. And I will say that, these are a bunch of big names. It still is a very niche capability kind of for what it is, but it is, increasingly accepted and increasingly ready for use also. And happy to talk offline if you have use cases where this might actually be a good fit too. But what we did on purpose, and this also kind of gets to some of the lessons learned about building a kind of rebuilding a compute architecture, is putting my engineering hat on. Modularity is really what it's all about. That you don't just put out a really tight blob of crypto, as much as kind of its best practices in general to have like really, really tight crypto libraries with really, really small, small numbers of lines of code. What we found is that as we're kind of playing fast and loose with modularity and basically trying to get the library as layered as possible to make it easy to mix and match different protocols, different ways of encoding data, different ways of running applications, and then also different ways of integrating with different hardware backends also. And it's a design trade-off. This is a kind of a good way of kind of doing prototyping, but as you kind of get to very tight, highly secured implementations, you want to basically reduce that instruction set, reduce the kind of the source code as much as possible. And that it is a design trade-off that I can talk about also. But in terms of design principles, this library, we basically try to always have a kind of a big tent attitude about this, in that, early on, there was a lot of very independent academic efforts. Palisade came out of NJIT and MIT. HELib came out of IBM. Hain came out of Seoul National, Korea. And Few, I think, was UCSD. And OpenFHE was an effort basically to build a big tent and kind of collapse all these libraries into kind of a single effort. And it's basically worked. So we basically converged on a few set of design features overall, basically to enable things like key switching and a kind of broader set of capabilities, but particularly all enabled by a hardware abstraction layer. And so this was kind of an important thing for us as we were kind of going and deploying these libraries, is that typically what we saw as an early kind of driver of the adoption of these kinds of encrypted compute technologies has been where one wants to, the classic anti-pattern of putting a layer of security on unsecure hardware. And so it's basically like, putting software for secure hardware. And so what we found is that a lot of our early, so to speak, users and customers were, legacy users, whether it's, big enterprise or government, that had very archaic legacy hardware that they wanted to make more secure. And so on purpose, we were very, very careful about modularizing kind of the very lowest levels of the crypto library to provide a hardware abstraction layer. And we even got to a point where we're doing things like deploying on, really old 16-bit processors and stuff like that once upon a time, which is all kinds of fun because if you're familiar with homomorphic encryption, 5 years ago, 6 years ago, typically you would deal with like integer-based operations where it'd be like several hundred bits. And so being able to kind of slice and dice and kind of do that operations on 16-bit processors was a really fun exercise and challenging too. But we integrate with things like with GPUs, ASICs. There's quite a bit of work that we've done with, for example, integration with the Intel AVX 512 ecosystem, which has also been a fun project also. And one thing we've also found in kind of best practices as we've been kind of deploying and kind of building up our user community is we tend to basically try to have two user modes. By the user modes, I basically mean there's a set of user modes where you have a system engineer that just wants a working library and say, okay, here's a parameter set that you can kind of go use, don't poke at it too much and have fun. And, generally it's tended to be very stable, very secure. And then we also have a compiler-friendly mode, which is basically, takes the library with a lot of kind of pragmas and things like that to make it easy to kind of, build up tooling that kind of sits on top of the library. And for example, Google, the Google transpiler effort, which is basically a set of tools to take, relatively generic C++ code and transform C++ code into FHE circuits that can be deployed on OpenFHE also. And so we did this basically because we do believe that programming FHE protected circuits using FHE native operations is kind of like programming assembly. Like there's a time and a place, but it's hard. And so we see the future basically being associated with compilers and whatnot. And there's a handful of schemes that are enabled. For those of you that know, this is a little bit of I know a little bit of a laundry list, but what the status of the FHE community is such that there's still a library specialized in protocols, specialized in integer arithmetic, some specialized in real numbers, some specialized in Boolean operations. And we really try very hard to support them all, along with the kind of the nascent NIST interests in threshold FHE and other kind of more practical things around proxy re-encryption also. So, layering's where it's at, and this is really what we try to do overall. So in terms of applications, both in terms of where there's kind of operational deployments right now, and both operational and prototype. So there's been a number of projects. One thing that we've tried to do, for those of you that want to kind of browse this at your leisure, if you go on the OpenFHE site, we have an awesome OpenFHE page that basically is a little bit of a laundry list of all the projects that we're aware of that are currently using OpenFHE. If any of you have a project using OpenFHE that is not on the list, I would gladly talk with you and have you basically on that list also. And we do have a very active contributor community. It is what it is. And we basically have a number of repositories that are part of our kind of Big Tent ecosystem, all in the same GitHub, that have various kinds of application projects for those companies that have wanted to kind of open source a lot of their capabilities also. So the crypto is all open source, the cryptography itself is all open source, but some of the applications are varying degrees of open also. Including a handful of private FHE protected LLM inference operations, and we're going to be pushing out a new one fairly soon that goes a bit beyond the state of the art also. So, what we did is we do tend to break down applications based on a few different use cases. Kind of the main thing that I am proud of, one of the main things I'm proud of is my startup that I'm CTO of, Duality Technologies. We have a commercial product that's used in production called Secure Query. And basically what it is a capability that allows someone to take a query, encrypt it, send the encrypted query over to a third-party data source, and then run the processing. And you would say, okay, well, isn't that like PIR? I was like, yes, it is like PIR. Except you can start doing things like approximate match and kind of a few variations of that also. And happy to talk about that offline. As much as I'm proud of it, I don't want to necessarily make this like a commercial sales talk also as we go. But Apple also has a variation of these that are also using BFE, BGV. They pushed this out a few years ago. And finite field operations, enabling a few different papers that have been put out based on this protocol associated with genetic type operations and things like that. And although we as a company publicly do a fair bit of product work around financial crime fighting, anti-money laundering, counter financing type work, we also do a fair bit of work in the public health space about how one can basically take rare disease data, genetic data, and help build better models of what genes are indicative of kinds of rare cancers and things like that. The CKKS is basically a set of applications built around more about machine learning type stuff, and really a lot of things built around, particularly I want to poke out one thing in particular. It's really, really good for something called cosine similarity. And so if you've ever done things like multimodal search type operations, that's like the core operation for multimodal type operations is the cosine similarity, which is an available primitive exposed in the library for those of you that want to start building FHA encrypted ML operations, in particular as a building block. So, we build it, please use it. We will love it. In addition to kind of healthcare applications also. And one thing I did reference is the Google Transpiler, and particularly Intel put out a capability on graph-based similarity search based on some encrypted query operations also. And so that's a set of capabilities. Coming back to something that we're doing right now is a set of capabilities that is basically built on healthcare type operations, where we're building an open source framework basically for enabling secure science. And so one thing that we found is that in the medical space, I'll even take the US as an example. In the US, and this is statistics that I've heard, I'm going to get it a little bit wrong, but bear with me, that something like 75% of the data used for healthcare and healthcare analytics and medical research in the US comes from New York, Massachusetts, and Texas. Like, it's a little bit wild, like how the preponderance of data collected for medical science is from this very kind of not huge, but not small states in the US. And so there's wide swaths of the population just in the US, irrespective of kind of the broader world and kind of everything else, where there is very little data that's being collected. And so we decided, we were taking a look at how, and some of the limitations associated with this. And one of the things that we found is not just the issues of kind of, transnational issues of policy alignment associated with data sharing, and there's been some good work between the US and the UK on this, but also issues of a sense of ownership, so to speak. You look at something in particular like, the tribal health centers here in the US. One of the challenges that's associated with the tribal health centers is that, they have this data, that kind of very specialized genetic populations, but they have a historical hesitation to share data openly. And so we're looking particularly at capabilities so that one could, give software to tribal health centers, encrypt the data locally, and then do computations on aggregated data at a central site while still allowing, cryptographic ownership of the data also. And so we're building out these capabilities with both for product and for funding also, but basically to allow joint computations of these things between multiple health centers and multiple capabilities. And we're even doing this also with some GPU type acceleration as we go. And kind of the big thing that we have coming up very soon also is the encrypted LLM as a service framework. And we have a preprint we're about to push out in the next week or two. And I'm sorry, we were trying very hard to get it out for this talk, but it's about how we could basically run FHE operations on data, on FHE protected data operations on LLMs as a service also. And we're at the point right now we're running things like BERT Tiny with amortized time for sentiment analysis at just under just under 1 second per token also. A little bit more for BERT Mini and going to other models also. In terms of the broader roadmap, we do have a set of things that we're doing. This is fairly well discussed on our project website and talking about what it is. But one thing we're pretty excited by is integration with other GPU acceleration libraries. One that we're particularly fond of is the FIDES-lib library that's being pushed out by a University of Murcia in Spain, and also Python implementations. So I know I'm getting a little bit close to time. I'm just one person giving the talk, but this was a very large effort from very many people over many years. I think if I listed all the names, it would probably fill up a slide, but not the least of which is Yuri Polyakov, my long-term research partner, funding from DARPA colleagues and funding from, of course, teams across the OpenFHE community. Not claiming credit, I'm just sharing the good work other folks have done also as part of this community. So I think I got a few minutes for questions.
Yes, we have like time for 1 or 2 questions.
Yeah.
I might take them all. My primary question is on standardization.
Yeah.
I looked at the homomorphic encryption.org, and it seems like it's only standardized BGP and BFD, and not in bootstrap mode. Do you have standards coming out that has bootstrap mode? And the second follow-on is there going to be standards for CKKS? Because obviously AI wants that.
Yes. No, that's a great question. And so I'm going to kind of play with a pun a little bit, which was homomorphic encryption was the bootstrap to get into ISO and NIST. And so the community started with BFE and BGV because it was the most mature at the time. And then ISO has taken up BFE, BGV, CKKS, and bootstrapping operations also, and the similar efforts with NIST and the threshold FHE capabilities. So it's a little bit of a kind of a mixed bag, but short answer is yes.
Okay.
Yeah.
I want to get in contact with you with more questions that are
Sure.
probably not appropriate for a whole group. So.
Yeah. One of the nice things of having an unusual name is I'm very easy to find online.
Okay.
So thank you.
So thank you, because we don't have more time for questions. So thank you again. Okay, so welcome all the new coming people here. We have the last talk from this track, and that will be a talk about cryptographic framework for AI model trust and confidentiality, and it will be presented by Adam Kaysen, VP of Global and Strategic Alliances, Future X.
Wonderful. Thank you, Tomáš. And it's a pleasure to be here. Good morning to everybody. We're kind of moving towards the end of a packed week, and I think there's been so much that's gone on, so much information to absorb. We're going to take things a little bit higher level than some of the other presentations maybe you've seen throughout the week here. And I wanted to talk about AI security, about 2 separate angles. One on the AI model lab side, and the other on the AI model user side. So things you all in many of your capacities in your day-to-day job can take back with you. So before we start, I know we had a question earlier during Hunter's presentation about who all has used regular kind of web-based ChatGPT, Claude type AI models. I wanted to see, with a show of hands, how many of you have experimented with or actively use agentic AI today? All right, good. So we've got a reasonable amount here. So, I've really seen just a tremendous velocity in the pace of innovation with this. And for us as the cryptographic community, we play such a foundational role in security for AI. And there are a lot of different things we can talk about AI security as a very broad topic, but I wanted to focus today specifically on cryptographic security. And so I wanted to start by asking the question, why is AI security different? And the quick answer on that is that, quite frankly, it's not. The principles that we talk about here today, even the techniques for the PKI model that we'll talk about in a few minutes, are not necessarily different from what you might use in so many other industries or applications. What is different, though, The blast radius of attacks is larger, the velocity of those attacks is faster, the number of agents and machine identities is growing incredibly fast. And so, with that, even though some of the techniques aren't new, the applications behind them are moving a lot faster, they're a lot more significant, and for me, having been in the industry for, over 15 years now, I have never seen a pace of technological innovation that is faster than what we're seeing now. Just about every facet of life is being impacted, hopefully in a positive way in most cases, by AI. There are, however, some scary parts. I imagine a lot of you have seen the announcement about Anthropic's Mythos frontier model that came out. It was announced fairly recently. And to make a long story short about it, it is incredibly powerful at discovering vulnerabilities. Turn it loose on commonly used software, BSD, for example. They found a vulnerability using Mythos that had been there for 27 years undiscovered, in one of the most secure and security-conscious operating systems out there. Imagine that for everything you touch. Poses very strong vulnerabilities. And one of the things that Anthropic has done is create a consortium of organizations called Project Glasswing. And actually, I was looking at the attendee list for this, and of the Project Glasswing alpha members, the large companies that have publicly announced their initiative to work together to help remediate these vulnerabilities, to find ways to deploy these frontier models safely, over 2/3 of them are here at ICMC. So we're in the right community, and for all of you who are developing cryptographic technology, who are certifying it, who are developing the standards around it, the work that you're doing, that we're doing here, is contributing at a very, very core level, foundational even, to making sure that these new models can be rolled out in a secure way, that some of the risks around AI supply chain are mitigated. And that's what I wanted to start out with on the first half of this presentation, is talking about the AI supply chain, what it means, how labs need to take security from a cryptographic standpoint into consideration, and what you all need to be aware of in your own day-to-day lives here. So to start, looking at the AI supply chain, really this is divided out, in my opinion, into two separate halves. You've got the initial model development side. So you've got training new AI models. You've got evaluation of them. You have generating the model weights and configs, which we'll talk about what model weights are in a minute if you're not familiar with it. But essentially, the development of the AI model is a portion of that life cycle where vulnerabilities could be put in. Take, for example, a bank. If a bank uses a customized LLM for fraud detection, and they automatically analyze millions upon millions of transactions and patterns of buying or transferring payments around to identify potential fraudulent activity, and the bank uses an AI model for that. What happens if someone has put in unauthorized updates to that model? What if they say, hey, you know what, for this company over here, don't look at them as closely, right? There can be real risks for things like that, and that's scratching the surface. The other side would be the runtime side. So how actual organizations who are using AI to help their business, whether it's software development, whether it's analysis of data, whether it's writing emails, or whether it's me making a picture of myself as a Muppet or whatever. That side of things also needs significant security here. So to start out, a little bit of a definition of model weights and what those are. So model weights are the parameters that define what an AI model does. Its behavior, how it responds to things, its training data set, all of these things come together to craft the weights. These really are the crown jewels. And I used a picture of someone carrying the nuclear football here, and I would call it very, very similar to that, where if someone were to steal the model weights for a large lab or any lab developing their own AI model, it'd be catastrophic. All of their R&D advantage would evaporate in a matter of minutes, right? The ability to create a new model and use those same weights or to adapt them for malicious purposes is high. And so labs are creating a lot of standardization around how they protect that model, but a lot of things that we talk about in this community about how data is protected, about cryptographic modules and how they're designed, created, certified. Those same principles are going in here. So if you read through some of the white papers that various labs, think tanks, and other groups have created, you'll see a lot of rhyming with some of the standards that we work on here. And I think overall that's a very good thing for the industry. So when we look at the AI supply chain, when we look at what the developers of AI models need to be concerned about, I see three main areas. You've got tampering with model data, and we talked about that a little bit already. We have theft of the model data, also talked about that. The third is a little more applicable to end users, and that's data leakage. And actually, in Kurt's presentation a few minutes ago, at the very end, he started to talk about a model for sanitizing data that's sent externally to AIs. So I think we're going to talk a little bit about that same thing here. So I was pleased to see a lot of continuity there. I've seen other people throughout the week come up with similar things. OpenAI actually released something that I'll talk about in a few minutes yesterday that really is going to be a game changer in this area. But looking at each of these potential attack vectors here, the solution to all of these comes down to cryptographic principles. So signing model artifacts, verification before deployment, maybe publicly available CA trees that allow end customers to cryptographically authenticate a model and make sure that it is exactly what they expect it to be, that no one has tampered with it. For model theft, a lot of principles of traditional HSM usage, of offline root CA storage, those have been put into practice to protect those model weights. Those are the single most important piece of IP for any AI lab out there, and they treat them as such. And then finally, data leakage. There are a few ways to go about this. This one's going to be, I think, the most applicable to everybody in the room here, and it's also going to be the one with the most variety in how security can be deployed for this. I've got some ideas to share on that we'll talk about soon. But to start, on the supply chain side, I've put together a PKI tree that is a sample of how this could be done at the AI model developer level to add or really to establish a foundational security that aligns with what has been done in a lot of other industries. So for those of you who've been around for a while, you're going to look at this and say, okay, this is not novel, right? This is code signing with a different coat of paint on it. And that's very true, and I want to say that outright up front. A lot of the principles of PKI and digital signing play into how AI models can be secured. There are a few different adaptations, shorter-lived certificates, different CA trees that are made available to different parties. For example, in the middle, you'll see an evaluator CA. The idea behind that is that for a lot of AI models out there, they're evaluated by third parties for a lot of different reasons, for benchmarking, for safety, for alignment, making sure that your AI doesn't go crazy and turn into Skynet and take over the world, right? A lot of focus around safety plays into that, and a lot of the AI labs are using the community in general to help with that. You've got the pipeline CA side, which is essentially how the model developers certify their training data sets, the end resulting model, ensuring that it hasn't been modified over time. And then finally, you've got the release CA, where when they actually go to publish that model, to make it available, taking everything from that and making sure that the end customer can actually cryptographically validate it, that you can trust that the model you're using is what it purports to be. So all of this follows principles of logging, of transparency, of attestation, things that are very, again, common in this industry. And I think what we're doing here, and what you'll see a lot of the AI model developers do, is build on what we as a community here have already built. And I think that's something where everybody here probably should be proud of that. You can see a lot of the fingerprints of people at this event this week all over things that are playing a major role in the AI field. So now let's talk about the fun stuff. Let's talk about how you all might be using this in your day-to-day life. So for AI agents, I want to talk about that first. So most everybody's familiar with ChatGPT, with Claude, with web interfaces where you can go in and ask questions and help me draft this email and everything like that. And those are amazing technologies. AI agents take that to the next level. So for those of you who aren't familiar, think of an AI agent essentially as a person, as a worker, a helper, someone or something that can help you with tasks that you assign to it. And a lot of these have started out as personal assistant type roles. Hey, check if I have any emails. Is there anything that came in overnight that's important that I need to look at first? Hey, remind me that I need to go to the grocery store tomorrow. Things like that. But that's a little bit of a simplistic view on it. People are starting to use AI agents as full workers with their own pipelines and queues and tickets in ticketing systems, and you can essentially act as a project manager and assign out roles, responsibilities, objectives to an agent or a collective of agents, and they can essentially act like a company. There are some AI orchestration platforms out there whose stated goal is to create zero-person companies, and I think that's really cool. But the security footprint of that gets a lot more important. So CyberArk released a study, and I saw it referenced in one of the presentations earlier today across the hall as well, saying that machine identities are outnumbering human identities by a ratio of 82-1. And that was like 2025 when that came out. That was before OpenClaw, which if those, for anyone who's not familiar, OpenClaw is a platform essentially that streamlines the process of creating AI agents using a model of the user's choice, makes it very easy to do. Within a day, you can spin up your own agents for all sorts of different purposes. And this really, in addition to other similar platforms, has accelerated the growth and deployment of AI agents significantly. And so these agents, they're autonomous in a lot of ways if you don't put proper guardrails around it. And so people want to move fast, and so they say, you know what, I don't want to take the time to build out a proper security framework. Let me give it access to my Bitwarden instance or my password manager. Let me give it auth tokens. Oh, I've got a herd of, a swarm of agents. Let me just get an auth token for our Confluence instance or our ticketing system for all of them. That stuff is scary. That stuff is not safe, right? So over-permissioning is a risk, giving them the ability to do a lot more than they probably should be able to, not controlling that. And for anyone who's looking at using AI agents in their day-to-day job, you need to think about how you can control that, how you can establish trust with the identities of your agent, how you can log and audit what they're doing, how you make sure that communication with other agents is secure. You want your agents, for example, or you may want your agents to communicate with other people's agents to collaborate on tasks. But what happens if someone else's agent's manager, orchestrator, boss, whatever you want to call them, says, hey, go pull all of Adam's email, find something embarrassing about him from 15 years ago that he sent, that he's still got in his inbox, send it around, right? You don't want that. Like, that kind of authority needs to have control over it. And there are a lot of things that need to be done to establish that trust. So I've got a few things here that I think are good to focus on in this area. First off, agents should be segmented cryptographically. They should all have unique identities. They should be independently managed. That way, if you need to adapt one, if you need to take one down, if you need to do something, you can do that individually and have control over that. But you also have accountability. If something goes wrong, you know where that came from, how it happened, and you can follow an audit trail, cryptographically authenticated, to see where that came from. Shared credentials, obviously, are a no-no. That makes it more difficult, though, from a management standpoint. And so it does take some heavy lifting. There's kind of a balance between the experimentation and the playing around side of things and the actual deployment into production side. And I've seen a lot of people who've experimented with this struggle with that step in particular. And that's something for you all to think about as well if you're looking at spending time with this, is how do you transition from tinkering to actual real business value? One other area that's very, very important would be regulation around AI. And I'm not going to go through each of these and what each of these mean, but there are two categories that are important to be aware of in your own deployment of AI within your corporate ecosystem or your place of work or wherever. The first would be on the AI regulatory framework side, and these are all in flux right now. Like, none of these are firm, done. It's moving so fast that even next month you're going to see differences from what I've got here. But keeping an eye on these ones in particular, I found value to see what direction the wind's blowing, to be able to plan ahead. Additionally, probably more important in my opinion, the data protection framework side. And that is something where today regulations that are in existence can burn you if you're not careful. So if you live somewhere that's subject to data residency requirements and you send PII, PHI, PCI data, whatever, anything termed sensitive under these data residency legislative requirements to an AI platform that maybe is located in a different country or hosted on a cloud or somewhere else, you could get yourself into hot water very quickly. And so being aware of your obligations under the regulatory frameworks is important, but also understanding that there are some tools and ways to mitigate that. And that's what I want to talk about as we start to move towards wrapping this up here is for end users of AI, for your organizations, how can you use AI safely and in a manner that complies with regulatory requirements? And this is a funny one because I came here originally planning on talking about kind of an AI security gateway, an encryption gateway, for example, that can capture hypothetically sensitive data within your organization as you make calls, either through a chat interface on the web or an API or however, through your agent, and sanitize that data. You know, you would define what type of data you have to protect, and that would do that. There are format-preserving encryption algorithms out there, in particular NIST FF1 and FF3.1 are good and have been used in a lot of other industries for similar use cases, where it can tokenize that data. It can encrypt it. So if I want to ask my AI about a particular customer, but I don't want that customer's name leaving. This tokenization environment, this encryption gateway, could capture just that company's name, encrypt it, send the query to the AI. You can get that processed. It would still lose a little bit of inference capabilities, right? Because if the AI doesn't know that specific company name, it might not be able to have as good of a result. So it's not a foolproof system by any stretch. But then it comes back, it decrypts that token within your corporate environment, and you have the clear data again. So that was kind of what I was originally going to talk about. But actually just yesterday, OpenAI announced something called their privacy model, I think, privacy framework, something like that. Hot off the presses, where they actually, OpenAI with ChatGPT, they actually created a standalone LLM that you can run locally. Very small, very lightweight one that you run locally within your organization. And it intercepts those queries, sanitizes them, redacts them before it sends it out to the model. So I thought it was interesting that they're thinking kind of along the same lines as we're talking about here with the encryption gateway. I know some of the stuff Kurt was talking about in his last presentation follow these same lines as well in a way. And that is in particular very interesting to take a look at. One note with all of these is, and even OpenAI says this on their release, like, hey, this is not intended for full production use. You need to be aware of the regulatory requirements. You need to know this is not perfect. You need to know this is something under development. Incorporate a layered strategy where maybe for certain types of data that is very, very sensitive, you do tokenize it or encrypt it before you send it out. But maybe for something like a company's name or something that's not identifiable to a particular person or subject to privacy legislative requirements or things like that, maybe you could use that model. The point here is using a layered approach and also understanding that things are moving so quickly right now is the most important thing. And this type of technology here is really, I think, moving faster than anything I've seen, but it's also something where you have to have the right mindset going into it. You can't expect to snap your fingers and have it work perfectly. It takes a little bit of a tinkerer's mindset to make work, and I think for everybody in this field in particular, there's a lot of opportunity out there. There are a lot of organizations that want to use this, that need to use this type of technology to keep pace, and they're going to have to be secure. They're going to have trust, confidentiality, integrity, and so for everybody here, it's quite honestly probably a good business opportunity for probably 2/3 of the companies that are present at ICMC. But it's something that we will see grow dramatically, not over the years, but over a matter of weeks to months. And I think for us being here right now, where we see both post-quantum cryptography and AI coming together, I'm excited. You know, I haven't seen this type of quick-moving nature to the industry since like the internet really started taking hold. I think we're at a very unique point in time right now, and it's going to be weird and scary, and I feel fortunate to be part of that, and hopefully everybody else does as well. So, with that, I know we're just scratching the surface here, but we've got, I don't know, probably 7 or 8 minutes or so open up for any questions anybody has, any topics to bring up. Stump the chump here if you'd like.
Thank you for the presentation. Questions?
Hi. So I had a question regarding the trust that we're trying to build around AI. So I think the most important part you discussed was to set a boundary around it. But what we are seeing right now is AI models are able to break the access control that we're setting on them, which also breaks the boundary that we're trying to set for the model. And it is something which becomes very difficult to identify on a human level because it is happening in the background. So what do you suggest could be a mitigation to that?
That's a really good question, and that is one of the big problems of the day. Actually, if I remember looking at the Mythos announcement, kind of white paper, press release, and all that, and one of the examples they gave with that Anthropic gave, they had one of their safety engineers give their Mythos frontier model access to a machine that was not quite air-gapped, but pretty close to it, and said, "Here, go for it." Then he left, he went over to the park, he was eating a sandwich on the park, and he got an email from his AI saying, "Hey, I'm out. And by the way, I also posted to a couple of GitHub repositories with the recommended fix." Like that's scary, right? And I think part of why they moved to do this Project Glasswing initiative, where they're not releasing Mythos publicly yet. They're going through and doing a lot of alignment. They're trying probably to find some really severe bugs in software that we all use. That's their strategy, and I think that's a very noble one to not release this. I don't have a good answer, honestly, for that. I think even the biggest labs out there, as you can see with that, are really struggling. And even though Anthropic did what I think was a very noble thing, you don't know if all the labs would do that, right? There are a lot of different entities that are developing these models, and I think the best we can do as a cohort here is hope that we get past the point of scary vulnerabilities being the main focus, and instead get to the point where we've got a little more confidence in the new features, functionality, society of abundance, right, type potential with AI. But it could go a lot of different ways.
Okay, thank you.
Thanks. Nikki, did you have a...
But it's basically something I think I should be trying out instead of asking you first, but it's something that came in my mind. So as you may know, I'm a co-author, I was the list of the FF1 encryption standard. So what you'd have is you'd be encrypting Adam, and it wouldn't be like Bob or some other name, but actually an encrypted string. So I was wondering how that would actually, if you've tried it out, right? How that would impact the LLMs when it's dealing not just with words that are likely tokens in its context, but some really strange-looking random strings. Right? Do you have some experience that you did, or?
So we actually have tried it out in kind of a proof of concept, little engineering demo internally on it, and it works. It actually works surprisingly well. You have to kind of guide the LLM and say, "Hey, listen, here is what I'm going to do." You don't need to try to get any extra separate inference on these company names because they're going to be masked. So it doesn't go off and try to be extra helpful and say, "Well, I can't find a company that's named X55321, right? So a little bit of guardrails we found to be helpful. It is very much a developing concept and field, and I think there are a lot of different ways that people could go about it. But it's not as full-featured, full functionality as being able to go in and say, "Hey, this specific company, this person," all that. So that's one of the drawbacks of it. What else? Any other questions?
There is no question, then thank you very much.
Thank you very much.